Hello, welcome to Economics. I'm Isaac Temidayo. Today we'll continue our discussion on regression analysis and we'll focus now on how to derive the OLS estimators of a two-variable regression model. So basically, the prerequisite to this is it's just about three things. We just have to focus on three things. One, we need the knowledge of the PRF, population regression function, the sample regression function, and their stochastic specifications. Then also a little bit of partial differentiation, and lastly simultaneous equation. So with these three, we are good to go with the derivation of OLS estimators. So you recall from the second video we had on regression analysis that we defined our PRF, our population regression function, as yi equals the expected value of y given xi plus the error term. So this is our stochastic specification of the PRF. Now from the equation on the board, I can always write ui to be yi minus the expected value of y given xi. Alright, now you recall also that the expected value of y given xi as specified by our linear regression model is beta 1 plus beta 2 xi. So which simply means I can always write everything here as ui equals yi minus beta 1 plus beta 2 xi. Then when we open this bracket up, we have ui equals yi minus beta 1 minus beta 2 xi. Now, given the fact that we are working with estimators, we are trying to derive the estimators, so we use our cap, ui cap, beta 1 cap, beta 2 cap, while we leave the other two variables like that. So from everything we have here now, the next step is we find the summation of the squares of both sides. We find the summation of the squares of both sides. That is, I find my ui cap square. So square both sides. You have yi minus beta 1 cap minus beta 2 cap xi. We find the square of both sides. Then having done that, then you take the summation of both sides. So summation ui cap square equals summation yi minus beta 1 cap minus beta 2 cap xi all squared. Having done that now, this is where we need our knowledge of partial differentiation. So we'll take the partial differential of summation ui cap square with respect to each of the estimators, that is beta 1 cap and beta 2 cap. So the first step is we'll take the partial derivative of this equation with respect to beta 1 cap. So we have this ui cap square with respect to beta 1 cap to be. So we'll bring this power down, then you write everything you have yi minus beta 1 cap minus beta 2 cap xi. You subtract 1 from the power, then you multiply it by the derivative of everything that is inside there. Remember, we are differentiating with respect to beta 1 cap. So the derivative of all this now with respect to beta 1 cap will simply be minus 1. We'll take all others parameters and variables as constants. So the derivative of everything that is here with respect to beta 1 cap is minus 1. So we simply have this that's minus 1 times 2 minus 2 summation yi minus beta 1 cap minus beta 2 cap xi. Then we set it equals to 0 to find the parameter we want. We set this equals to 0. So from what is here now, I can divide both sides by minus 2. That is, we have 0 over minus 2, and that gives 0. So that simply gives us summation yi minus beta 1 cap minus beta 2 cap xi equals 0. So having divided both sides by minus So from what we have here, I can open up with summation. I can open this bracket up with summation. I have summation yi minus the summation of beta 1 cap minus the summation of beta 2 cap xi equals to 0. So here we do a little bit of arrangement here. Now it's very, very important to note that the summation of your constant, we are treating our beta 1 cap as a constant, is a parameter. The summation of your constant is simply n, that is the number of terms multiplied by that constant itself. So I have summation yi, the summation of beta 1 cap will simply be minus n multiplied by beta 1 cap. So minus, since we have a variable in front of beta 2 cap here, you can always bring this constant out, beta 2 cap, you can always bring it behind and have summation xi equals to 0. So having done this arrangement now, then I have summation yi minus beta 2 cap summation xi as equals to n beta 1 cap. So the goal here is to find beta 1 cap. So n beta 1 cap is also the same thing as summation yi minus beta 2 cap summation xi. Then I can always divide both sides by n. Therefore, beta 1 cap equals summation yi over n minus beta 2 cap summation xi over n. Now, summation yi over n represents the mean of yi. So, minus beta 2 cap summation xi over n also represents the mean of xi. So, we have the slope parameter, we have the intercept parameter, we have its value as the mean of y minus beta 2 cap multiplied by the mean of x. So beta 1 cap is the intercept parameter. That is the intercept parameter. So this is how we derive the intercept parameter. Therefore, we have beta 1 cap, which is the intercept parameter. We have its value as yi bar, the mean of y, minus beta 2 cap, the mean of xi. So this is how we derive the intercept parameter. So you of course you see from here that the value of beta 1 cap is also dependent on beta 2 cap. So we need to proceed to find beta 2 cap. And how do we do that? Just with the knowledge of simultaneous equation, as I said earlier, and partial derivative. The last thing we did here about partial derivative is we differentiated this equation with respect to beta 1 cap. So the next thing now is we'll find the partial derivative of our ui cap square with respect to beta 2 cap now. So that's the next thing. So the summation so we have this with respect to beta 2 cap as we bring the power down also. So you have 2, then you write everything that is inside yi minus beta 1 cap minus beta 2 cap xi. So we subtract 1 from that power, we have raised to power 1 here. Then we multiply it by the derivative of everything that is inside here, but with respect to beta 2 cap. So you have minus xi there. Minus xi there. Of course, when you differentiate everything that you have here with respect to beta 2 cap, you have minus xi. Then you set it equal to 0. Equal to 0. So I can always rearrange that as minus 2, these 2 multiplied by minus xi, minus 2 xi summation yi minus beta 1 cap minus beta 2 cap xi equals to 0. this is a variable. I can always bring this variable in front of this summation. So that makes sense like that. We have this multiplied by yi minus beta 1 cap minus beta 2 cap xi equals 0. So having done this now, the next step is you divide both sides by this minus 2. So when you divide both sides by minus 2 goes here and you have 0 over minus 2 and that gives 0 automatically. Therefore, we have summation xi multiplied by yi minus beta 1 cap minus beta 2 cap xi equals 0. So let's open up this bracket and let's see what we have. Summation xi multiplied by yi, we have summation xi yi minus summation xi times beta 1 cap summation xi minus summation xi multiplied by beta 2 cap xi beta 2 cap summation xi multiplied by xi, you have xi squared. So that's xi multiplied by xi, you have xi squared. Everything equals 0. So also we have summation xi yi equals beta 1 cap summation xi plus beta 2 cap summation xi squared. When you take everything here, when you take it to the right hand side, so we have this. Now you will recall that, note, we already have beta 1 cap as summation yi over n minus beta 2 cap summation xi over n. So what we'll do now is that we substitute this beta 1 cap, we substitute its value back into what we have here. Therefore, summation xi yi equals everything here now beta 1 now. Summation yi over n minus beta 2 cap summation xi over n. So everything here multiplied by summation xi plus beta 2 cap summation xi squared. So we just make a little substitution here. What we have as a value of our beta 1 cap. So we substitute that back into here. So we have summation xi yi equals. So let's open this bracket up with summation xi. Summation xi multiplied by summation yi, we have summation yi summation xi divided by n, this n, minus summation xi multiplied by beta 2 cap summation xi, we have beta 2 cap summation xi multiplied by summation xi, just like you have a multiplied by a, that will give you a squared. So you have summation xi all squared, summation xi all squared. So you have two summation xi there, plus what you have there, beta 2 cap summation xi squared, and this is over n. So we don't ignore that, we have over n there. Now the goal here is to find beta 2 cap, and we have two beta 2 caps in this equation. So that should give maybe an insight that we have to do factorization here. So let's collect the like terms. We'll bring this guy here. So we have summation xi yi. Let's bring our friend here to this side. Minus summation yi summation xi all over n equals. I can bring this forward, and now beta 2 cap summation xi squared minus beta 2 cap summation xi all squared. Alright, so here we have over n summation xi all squared over n. So let's collect the like terms since we have to find beta 2 cap. So we'll bring this guy, bring our friend here, we'll bring it to the left hand side, and we have summation xi yi minus summation yi summation xi over n equals. So we can do a little bit of arrangement here. We'll bring this forward and we bring this to the back. Beta 2 cap summation xi squared minus beta 2 cap summation xi all squared divided by n. So we have n as the denominator here, n as the denominator here. So why not multiply through by n? So multiply through by n. When you multiply through by n, you have n summation xi yi. So you multiply this term by n, the n cancels out, and you have minus summation. Okay, this is the same thing as summation xi summation yi equals. When I multiply these two by n, I have beta 2 cap n summation xi square minus, when I multiply 2 by n, the n here cancels the n here, n at the denominator, and I have beta 2 cap summation xi squared alone. So we got this by just multiplying through by n, term by term. So I can factorize what I have on the right hand side, and I have some n summation xi yi minus summation xi summation yi. When I factorize, I bring beta 2 cap as the factor, as the common factor to both, and I have n summation xi squared minus summation xi squared. I can say, therefore, beta 2 cap will be dividing both sides by n summation xi squared minus summation xi squared. Then you have n summation xi yi minus summation xi summation yi over n summation xi squared minus summation xi all squared. And this gives us the parameter, the estimator of our slope parameter. Note that beta 2 cap is the slope parameter. That is the slope parameter. So with that, we have an estimator for our beta 2 cap. This is how we get it now. Now it's very, very important to know that. Okay, let's give a summary of everything we've done. We have our beta 1 cap, the intercept parameter, to be the mean of yi minus beta 2 cap multiplied by the mean of xi, where beta 2 cap, that's our slope parameter, equals n summation xi yi minus summation xi summation yi divided by n summation xi squared minus summation xi all squared. Now the slope parameter here can always be written in derivation form, and when you write it in derivation form, you have this summation small xi small yi over summation small xi all squared. Yeah, that looks very, very compressed. Summation small xi small yi over summation small xi squared, where you have small xi as big Xi minus the mean of x, and you have small yi as the big yi minus the mean of y, So this is the deviation form of our slope parameter, and this is the normal form of our slope parameter. So also we have this as the form of the estimator of the intercept parameter beta 1 cap. Now it's very, very important to note notational changes. Sometimes your beta 1 cap, that is your beta 1 cap, the intercept parameter, might be represented as beta 0 cap in some textbooks. So of course the process remains the same, you just change the notation. Sometimes the intercept parameter might be represented as alpha. So it's just very, very important be aware of the notational differences. If beta naught cap is used as the intercept parameter, then the slope parameter might now be beta 1 cap. So the process remains the same, but you just have to be aware of the changes in notation. So it might be alpha 1 and alpha 2, where you have your alpha 1 as the intercept parameter and you have your alpha 2 as the slope parameter. So the basic thing to note here is that if you want to derive your intercept parameter, then you follow this process, regardless of the notation, like the alpha 1, beta naught, or anything. So you just change the notations. So, and if you are finding your slope parameter, the process also remains the same. Alright, so we've come to the end of this class, how to derive the OLS estimators of a two variable regression model. So please, if you have any question or anything that is not clear, kindly let us be aware of that in the comment section. And please also subscribe, turn on notifications to get updated about our subsequent classes. So see you next time. Bye.
Hope you enjoyed the video you just saw. If you want more of our videos, please make sure you subscribe to the channel and click on the notification bell. Now, there is a way to enjoy, to make the best of our YouTube channel, which is to go to the playlist section of every video or of every topic. So what you have to do is just type Microeconomics on YouTube. When the page displays, make sure you subscribe. A bell button appears immediately, so you click on that bell button. Then go to the playlist section. So you're going to see videos, playlists, description, and all of that. So just go to the playlist section, and whatever topic you are looking for, look for the playlist and click on the video. Now, our playlists have their classes, the classes arranged in a very chronological manner. So if you want to see a class on ISLM, so it starts from the beginning, the simple ones to the difficult to the complex ones. So if you want to see a video on, let's say, elasticity of demand, so you start from what is price elasticity, so from there then to the basic ones, and on and on. So I'm just telling you that in case you really want to make the best of this YouTube channel. And there's also one thing that I want to add, which is that our YouTube classes may not be enough for you. You may want a regular interaction with the tutors and all of that. So what you just have to do is to check the description of the video. You are going to find a WhatsApp link. So, but before you do that, I really have to tell you that clicking that link is going to lead you to one of our schools. It's going to lead to some of our schools. So we have MOG School of Economics on WhatsApp, and we make use of our YouTube channel to run the groups. So the classes are paid for, so you're meant to pay for them. So to join our Econometrics school, so that is 2,500 naira per month, and to join our Microeconomics or Macroeconomics schools, so that is 2,000 naira per month. We also have we don't have schools of mathematical economics because Microeconomics has its mathematical aspects as well as macroeconomics. So the mathematical aspect of macroeconomics is treated in the macroeconomics school, and the mathematical aspect of microeconomics is treated with the microeconomics school as well. So I'll see you next time. Thank you very much for watching.